Hi, my name is Saad Suleiman. I'm 10 years old, and today we're going to do something that I mentioned in my video about phosphorus but kinda held it off. And that we're gonna do today. We're gonna discuss ionic and covalent bonds, the two types of bonds, and then we're going to see them in action with an experiment. So let's begin. There were two types of bond. There is ionic bond and there's covalent bond. Let's first discuss covalent and an example. Covalent is when two atoms, this is a rough drawing, come together and they share their atoms, okay? Now, for example, let's go with that over an example of phosphorus. So phosphorus, do you remember? Its outer shell had how many electrons? It had 5. 1, 2, 3, 4, 5. Then how many do they, okay, let me write it over here. Phosphorus, just a short symbol. How many did they need to become full? They need 8, right? Yeah. So he needs 3 more to become. Now, this is another example. Imagine another atom strolls along with 3 electrons in its outer shell, and its name is boron. Yeah? And they talk to each other and they say, well, boron says, I need 5 more to become, because if they get 8, they become balanced, kind of. Kind of like they get calm. And right now they're really restless. They just need 8 and then they get something that's called inert. Yeah, inert. For example, an inert gas. So he says, I need 5 more to become inert, and he says, I need 3 more to become inert. So why don't we share, and then we'll both become inert? So they share. And then, as I said, 1, 2, 3, 4, 5. I think you remember. They go like this and like this. And they keep on sharing. But the thing is, this isn't as strong as ionic. Because they aren't that good friends, they're just sharing, you know. And I'll show you how ionic is much stronger. And so if any outer force comes, he can take his 5. And he can take his 5. Alright. So this was covalent bond with an example. This is really jumbled up. I hope you understood. So let's see ionic bond. Okay, I told you that this isn't as strong. The covalent isn't as strong as ionic, right? Because they're always they're just sharing with each other. So if a fight breaks out or something, then they can just say, you take your thing, I'll take my thing. But how is ionic much stronger? You see, let's take sodium. Okay? Actually, fluorine and sodium. Or actually, chlorine. So, if you take chlorine, it has 7 in its outer shell. 1, 2, 3, 4, 5, 6, 7. So it has 7 atoms in its outer shell. Okay? Actually, I'll change my mind. I won't use sodium. Chlorine has 7. How many more does it need to become inert? Okay? It needs only 1 more. So this is chlorine. It's written here. Along comes some other guy, and his name is hydrogen. I think I've heard of him before. Hydrogen. And he only has 1 in its outer. He says that, hey, I need 1. And he says, yeah, I don't have to do anything with it because I still need 7 more. I'll just give it to you forever. And now he gets 1. And now he's happy. And he has nothing left. He. Poor guy. But then he says, you give me a great favor, man. Thanks. So then they become friends, but they're much stronger. These two are only sharing. He gave up his only thing, like for example, he has $7 and he needs 8 to buy himself something. I don't know. Let me give an example. Some food. He needs $8, but he only has 7. He only had $1. He can't buy anything with $1. So he gave him the $1 so he could buy the food. And he said, you gave me a great favor. So why don't we become best friends? So they become best friends. But obviously elements don't talk like that. So how does it actually happen? So when he gets this thing, he gets positively charged. This chlorine. 1, 2, 3, 4, 5, 6, 7. Because he has 1 more than the original element. What keeps him the same is the inner. And hydrogen gets negative because he has nothing else. So remember how in magnets, I made another video on that. In magnets, North Pole and South Pole like each other. Similarly, positive and negative like each other, so they attract and become best friends. Another example, I'll just give it in short. For example, chlorine also loves bonding with sodium. It also has 1 in its outer shell, sodium. And when they bond, they're known as sodium chloride, better known as salt. Haha, you eat ionic bonds. Oh yeah, another thing, really interesting. So if this thing gains 1 or loses 1, they become something known as an ion. For example, in charging, when you charge your mobile, they use lithium ions. For example, they are lithium ions with 1 electron less. So they are an ion. These bonds are formed by atoms becoming ions, right? No wonder it's called the ionic bond. Ha ha ha! Oh yeah, I forgot to do a correction. It isn't actually positive and negative. This one is actually positive and this one's actually negative. I'll tell you why. Remember, I told you for the video of phosphorus that electrons have a negative charge, okay? He got 1 negative more, so he is -1, okay? He lost 1 negative, so he's +1. That's actually what happened. That's what made them all of it, okay? Now, let's go to the experiment. Woo-hoo! Yeah, there was one more fundamental concept I had to tell you before the experiment. And that is a catalyst. No, not a cat. That's a... no, it's not a cat. Something totally different. I told you, right, that when they come together, the atoms, they come together like this, right? When they come, sometimes if they're not alone, they can create different things. And something can happen. And that is called a chemical reaction. For example, the one we were about to do the experiment is actually a chemical reaction. And I'll tell you about a catalyst in a minute, but I'll tell you an example of a chemical reaction, a simple one. You know, if you leave wet iron, especially wet iron, like an iron nail, if you leave it for a long time, or a key, an old key, it forms like a powdery thing around it, rust. I think you know it. So that orange powder thing, rust, you know, that is actually formed by a chemical reaction. Iron loves oxygen, okay? So when iron meets oxygen, it just brings it in. And when it comes in, the oxygen creates a small layer, because iron also changes its color a little. It creates a small layer. That thing is actually oxidized when oxygen is mixed in. You call something oxidized when oxygen is mixed in. That's actually oxidized iron, that rust. And that also has, Mars, it's all red, it's called the red planet. That's actually because there's a little iron in its crust, on the ground. And that has oxidized. And that's actually rust that makes Mars yellow. Alright, so this was an example. Come on, I keep on wandering. So then, what was I telling you about? Catalyst. So sometimes, for example, iron, when you rust it, it can take ages for it. Like, you leave it there for years and then it oxidizes. So some reactions take really long. So that's where the catalyst comes in. A catalyst is something, it doesn't actually change in the reaction, because most things, they change in reaction. Let me give you another example, man. Iron and sulfur, if you make them react, they become something called pyrite. That's like a rock or something. But the thing is, once they react, iron, for example, is magnetic and sulfur is really cracking. Pyrite has changed. Pyrite is not magnetic and nor is it really brittle. But the catalyst, when it goes into a chemical reaction, it doesn't change. You can use it again and again if you know how to collect it. We don't know how that. Anyway, but the thing it does on the experiment, you know what it is? It speeds it up dramatically. Like iron. I don't exactly know the catalyst for rusting, but there is a catalyst we're going to use. By the way, platinum is a really common catalyst. It's one of the terrific party starter. Anyway, now let's move on to the experiment and I'll show you where the catalyst is. Alright, now we need a few things. One, you can make a paper funnel at home. See, I taped some paper together. That's it. And then there is food color you need too. Some washing up liquid. Whoa, don't fly away, mister. And then you'll need some white vinegar and some baking powder, okay? You'll also need, did I even bring it? Oh yeah, it flew away. Okay. You'll need a plastic bottle. You'll need a dessert spoon. And you'll need some big bowl or anything that this can fit inside. Try to do this outside because it can get a little messy. Alright, let's start. Let's take 60 milliliters of, now I'm not sure how much to put because I don't really have a measure. 60 milliliters, I'm just going to go on approximate. Approximately this much, perhaps. I hope I didn't go overboard or underboard. Alright, next, a few drops of food coloring. You can use any color. This is food coloring, yeah. Okay. Oof, I think I put a little too much. I think that's fine. Anyway, now, time for the catalyst. This is the catalyst. Remember the catalysts? Actually, the main reaction is this and the vinegar, okay? But the problem is, it goes pretty slowly and it don't do that much. Actually, I've tried it before with no catalyst, no food coloring, nothing. And it only just makes a few bubbles. and just dies away. Alright? But this time we're gonna do a catalyst. And then also a few drops of washing liquid. Mr. Catalyst. 2, 3, 4, 5. Oops. Uh-oh. I'm gonna wash my hands because I dropped some. Okay, it's clean now. I hope it isn't very acidic. Anyway, so don't do this without supervision. And now, time for the funnel. Funnel fun, I call it. Alright now. Now it's time for the large bowl. By the way, make sure for the large bowl or anything else, because this is so a mess precaution. Can you see it? No, you can't. Anyway, bring this up. And next steps, I think I should bring it slightly. Yeah, this is perfect. Next step is 2 dessert spoons of baking soda through the funnel. Baking soda, baking powder, same thing to me. Okay. I'll need to call for help because I am not sure how to bring teaspoons out of this. Alright, you pour it and I'll pour them. Quick. Swirl the bottle and stand back. You see it? It rose. You saw it, right? I think I should add a little bit more. Or perhaps a little bit more of this. Or vinegar? Vinegar could be the issue. Vinegar. Okay, vinegar. Let's put vinegar. Slightly more. Whoops. Most of it came out, man. Okay, and now baking soda, I'll just put it like this because we're in a hurry. We don't want it to expire. See it rising? You saw it? It was over here. Usually it would have come up till here, but the catalyst. Should I pour it? Or perhaps swirl it? Okay, now let us swirl it. Should I pour it down to show you the foam? Or should I add some? It is rising. Usually it isn't as good as this. It's a terrific improvement. I was saying messy for smaller bottles. This is a big bottle for this experiment. Don't use too big a bottle, you'll see nothing at all. You see all the foam? It's become foam. That was the chemical reaction. Something in the baking soda bound with the white vinegar. And this, oh, no, not again. This thing bound it up. Maybe there's something wrong. I don't think so. I'm gonna swirl it. Can you see inside? This is all perfect. Now this showed the chemical reaction. This was a bond between two elements. I'm not sure which bond it was. I think it's a covalent bond. Because this don't last long, I can tell you that. After like 10 minutes, it starts smelling weird. Yeah, it is smelling weird right now, if you sniff it. And the bubbles disappear. Let's see. Ooh, oh, you see? This was the byproduct. The washing liquid and this thing. See? I told you they don't get used, right? Let me show you again. They didn't change at all. They just sped up the reaction and made it much more dramatic. See, you can see them at the bottom. You can see them at the bottom. And I told you, right, that the reaction dies down? You remember where it was. See where it is now. Let's show you. Oops. Foam ain't coming out. No, it ain't. Let's show you. Here it is. Oh, man. It's totally died. See? Now, not much is left, but I can guarantee you there was much more. Well, this was today's video and its experiment. Hope you enjoyed it. Bye! I just wanted to show you. Told you it was a covalent bond. Something's breaking apart the foam. See? There's barely anything left. Alright, bye. Real bye.